بسم الله الرحمن الرحيم رب زدني علما.
So the next thing we'll also see how we can make a router as a DHCP client. Now, most of the time, like in some scenarios, a router can also be a client. Like in the previous example, we have seen how we can make a router as a DHCP server, assigning the IP addresses to the clients. Now we'll see how we can, or how we can, or what are the different scenarios where the router can also be a client. Okay, which means the router will request the IP address and get the IP address. Now, this is more applicable in a simple home network. If you take a simple example of your home network itself, in your Wi-Fi connection, like let me show you here. Let's take an example. I'm connecting to my Wi-Fi connection in your home. Mostly everyone uses Wi-Fi. So you got some devices already connected here in my LAN, my laptop, my computer, and mobile devices. And I'll be using the Wi-Fi router, which is a box in my network. And of course, through the switch, I'm connecting all these devices. Now, one thing we need to understand here is this particular Wi-Fi is enabled with a DHCP service, which is going to assign the IP address from whatever the network. Okay, like in my case, it is 192.168.15.subnet, which I'm using. So this is going to act as a DHCP server, which is responsible for assigning the IP addresses to the clients. But normally, if you observe, that particular device, the Wi-Fi router, also will be connecting to the ISP. So there is a WAN link which goes and connects to the service provider, and the service provider will maintain the DHCP server, which will be assigning the IP address to the WAN interfaces. Which means now here you have to assign the IP. Mostly it can be a public IP or it can be whatever the IP, and this IP will be decided by the service provider. So you're not going to decide the IP because mostly this is not my network, right? It's a network connecting to the service provider. So now for this example, if I just get back to this example here, now for this example, it can be either a static IP or it can be a dynamic IP address. Like I said, this public IP, whatever the IP is given by the provider, this can be a static IP, mostly, or the dynamic IP address, where you are expected to get the IP address from the DHCP server. Okay. Now, again, it depends on your agreement with the service provider. If you pay for the static IP, he will provide you the static IP. That will not change. You can manually configure that IP. Now, the other example I can just say this can be a Cisco router as well. So if you take the same scenario with your production network in the real network, this can be a dedicated Cisco router which is connecting to the service provider. Okay. So now in this case, if it is a static IP, I just go to the interface F0 by 1 and we just give the IP address and we know how to do that. Okay. So typically in the home connections, it cannot be a static. So it will be always public. And this WAN IP, if it is dynamic IP, then I need to go to the interface F0 by 1. I just need to say a simple command called IP address DHCP. Okay, this is the command. So which means I'm saying that this interface should be getting the IP address from the DHCP server. Okay, so that's what here. Okay, so the router as a DHCP client is more applicable when you are connecting the remote branches. This can be like maybe you have a head office, a DHCP server, assigning the IP address to the clients, or you can take this as a service provider, assigning the IP address to these interfaces on the WAN interfaces, connecting to the internet, or it can be other things. So the different examples, I already explained the home network. We already discussed that. And also it can be equivalent branch office network using a dedicated Cisco router connecting through the public network or through the internet or through some MPLS or any other connections. Okay. Or even in some cases, it can be a specific wireless service provider deployments. If you're using any kind of wireless service provider networks, also it can be the same. You can say like remote devices will be getting the IP address from the DHCP server here. Okay. Now, what is the configuration we have to do? Simple. We just need to say IP address DHCP. So to quickly verify this, I'll try to add one client router, assuming that this is assuming that it is assigning the IP address. Of course, I'll add on the remote router as well. So what I can do is, for a quick verification, I'll try to add one more router here. You can see I already have the routers or the remote LAN. We'll just extend this topology a little bit as we move on. And I'm going to do the connection. So there is a cross cable, or I'm going to connect it to F0 by 1 interface. And what I'm expecting is, in this scenario, there are two ways. Let me show you the simple way. One way is assuming that if you have a router in my network and you want to assign the IP address, on the same, you can just use this example. And this is already pre-configured. If you verify with show IP DHCP bindings already, or if you say show run section DHCP. Now these commands are important in terms of troubleshooting later on. You can see already it is pre-configured with the IP pools, and I'm expecting this device should be getting the IP address dynamically. So before that, just make sure that this device is up and running. So what I'll do is I'll go to my client DHCP and I'll simply say IP address 0. I'll simply say IP address DHCP. And I'm going to say no shutdown to make the interface up. Now again, if you remember, there is a spanning tree option, because the spanning tree will by default goes through listening and learning states. There is a delay. This is something you normally see. There is a delay. So port number 6. So to skip that, I can simply configure spanning tree port fast. Normally what I do, I'll go and say F0 by 1 to 6. Spanning tree port fast. I hope this is basically a switching concept, because what generally happen is, if you just quickly review, whenever you make this interface up, it will take at least 30 seconds to listening and learning states to become up. So we can bypass that by using port fast feature, which will immediately put the port into forwarding state. And that's what I did here. And once I do this, now what I'm expecting the client must be getting the IP address. So this is my client, and I'm expecting the client has to get an IP address. Just I'll set shutdown and no shutdown to quickly get an IP address and request the DHCP server and get the IP address. That's what I'm expecting. I'm expecting some console message normally. So let's quickly, because this port fast I should have enabled before only. So not this F0 by 0, sorry. Yeah, F0 by 0 only, right? Shutdown command and no shutdown command. So I'm expecting this client is going to send out a request to the DHCP server. DHCP server is here to get an IP address. And as per the scenario here, let me just remove the connection and reconnect it, because this is a simple software issue might be. You can see here, I just removed the interface. Now you can see the console message indicating that this F0 by 0 interface is assigned with an IP address of 1.16. So you can see I'm getting the IP address because it is on the same subnet. Obviously, it will be getting the IP. And if I go back to my server and check show IP DHCP pool to verify the pool, what is configured and how many IPs are being leased, how many has been excluded, total IPs how many. So you can always verify this pool command for checking out the allocated IPs and the available IP configurations. And if you want to see the bindings, specific MAC2 binding, you can see this is the MAC address and the IP bindings, another verification command. Now, this is the same example what we have been discussing here. Okay, the router has a DHCP client it must be getting the IP address. Now there is one more example I'll try to configure here. Now in this, what I'll do is I'll try to configure in this example. If you see, this is going to be my DHCP server and this is my client. And of course, all these devices are my clients. Now what I want is I want this DHCP server also will be providing the IP address on this interface. So this is going to be my client IP where the IP address, it has to take it dynamically. And we can correlate this with a live scenario, like I can say like this might be a service provider having a DHCP server, and it is going to assign the IP address to this. Okay, so I'm going to use some IP like 10.002 here, 10.001 here, or vice versa, and I'm using 10.000/24 subnet on this. Okay, so anyway, this lab I'm documenting on the other side, but still we'll do this. Okay. Now, the one thing we need to understand here is on the DHCP server, if you verify the DHCP configurations, like if I say show run section DHCP, you will see there is a DHCP pool which is configured for 192.168 1. Subnet. So this is specifically used for this subnet. And this is going to be a separate subnet. So basically, this is a separate subnet. So which means on the DHCP server, when you have multiple networks, we have to create a separate pool. So which means I'm going to create a pool, let's say the WAN connecting to router 2 or router 3, whatever the name. And I'm going to say I'll be using a 10.network with /24 subnet. And default router, we don't have the default router, but just assume 10.2 is my default router. And what else I have to do? And any address you want to exclude, like I want to exclude from this 10.002 because that is going to be my own IP address, right? And we did not configure the IP, so it's an F0/1 interface. We also need to assign the static IP on that interface, 10.002 with 255.255.255.0. Okay, that's a interface IP we have to configure. Okay, so what we did, as per my configurations, I configured this interface IP and then I created a pool. So two things I have to do here. One is the IP address, and the other one we have to configure the pool for this network. And on the opposite side device, what I'm expecting the opposite device must be getting the IP address automatically on the WAN interface. So this is my router 3 or router 2, interface F0/1, and I'm saying IP address DHCP, and I'm simply saying no shutdown command to make the interface up. Now I can see immediately I'm getting an IP address from the pool. So 10.001, and the reason is simple. Whenever the client sends a request, it is receiving on this interface. So obviously it is going to check if there is any pool configured with this subnet, and it's going to assign the IP address to that particular pool. So this is a typical example for the same thing. You can see I'm getting the IP address 10.001, and I'm also able to communicate with the opposite device, assuming that the connectivity is perfect. So this is more like a service provider and the client scenarios, where you have the client customer getting the IP address from the service provider DHCP. Either way, if you're working for a client, or you might be working for a service provider, or you can take like this might be your head office offering the IP address to all the branch offices. It can be either way, okay? But mostly we don't do it on the branches because typically service provider will be having plenty of customers. So it has to use the DHCP to give the IP address in most cases, okay? So this is a typical or another configuration example where we have seen how we can get the router as a client. One example, we configured in the same LAN and requesting the IP from here. Another subnet requesting the IP on the opposite side. So verifications wise, you can again verification, the same command, show IP DHCP bindings. We can see this is the IP address given. And if you verify show IP address DHCP pool, it will show you what are the pools. The pool, this is one pool and this is another pool. And additionally, you can also verify the configurations by using showrun section DHCP server, which will show you there is a separate pool for the local LAN and there is a separate pool for the remote LAN as well.